All right, here we are continuing on with the Terrain Manager. So what do you got lined up in this video, Lee?
Magic.
Magic, ooh,
Magic. Lots of
gotcha.
magic. And, well, in celebration of the final Harry Potter coming out today, so I figured I'd have to work
Oh,
my own magic.
look how slick you are. All right, well, show us some magic.
Okay, well, if you guys remember from our earlier session, we had this big, long list of methods that were handling adding patches to the add patch list and then removing patches and deciding adding patches by row and all that really nastiness.
Mm-hmm.
This is a much more elegant solution that I came up with. So what we're going to do is we're going to make a list. I'm just going to call it patches as lowercase. So this is going to be a new list of vector 2s. Now I just need to keep track of the offsets for these patches. Don't really need to create the patches themselves yet. So what I'm going to do is make a couple of nested loops. So this is going to be X. And what we're going to do is we're going to check or loop through X equals minus tile size count to tile size count, or tile side count, not size count. But I want to also make sure that it's less than or equal to, because I want to get that last one. Otherwise, we'll have an unbalanced set of patches created. I'll have one less on one side than I would have otherwise. The second loop's going to be for our Z. And in this case, it doesn't really matter if I do loop through X first and then Z, or through Z then X. Just doesn't really matter. I'm going to get rid of these. I'm going to do a conditional check. That's going to say if patches dot contains key. The key that I'm going to be looking for is going to be our, well, how do I want to do this? Let's put this back in here because I'm going to reuse this a couple of times. So we're going to call this our position. So POS for position equals a new vector 2. And I will take our new vector 2, which will be X and Z. To that, I'm going to add our current patch location. Then I'm going to check to see if our patches already contains a key for this position. If it does, I'm going to exit out. But if it doesn't, I want to add this key to our patches list, this one right here. So patches.add, and we're going to add our position to it. So this is basically looking at our current position and then figuring out the grid of our interest range to left and right of our current position, and looking at those patches and saying, hey, do I already have these patches created? If I do, then just skip them. Don't worry about it. But if I don't, I need to do something with them.
Mm-hmm.
So I'm going to put them in this temporary patches list so I can queue these up to be created. But I don't want to just create those right off the bat and say, I'm just going to create them regardless. There's a couple of things that I want to do before those are queued up to be created. So what are the things that I need to do? Well, I need to check how far away they are from the player, because if they're right under where the player is or right near where the player is, I want to give them a high priority so that they get created first regardless. I also want to check their position relative to the camera.
Mm-hmm.
So that only the patches that are in front of the camera are created. So what I'll do is a for each loop. It just says basically for each patch, well, in this case I'll call it POS to keep it similar to this. So for each position in our patches list, I want to do some checks. So we will take our, let's see, var camera rotation y. So rot y is going to be equal to our camera dot main camera dot transform dot rotation dot Euler angles dot y. Yeah, you don't have to dig very deep for that, do you? Now, because I'm going to be using some trig functions on this, I need to have the radian version of this. And when I pull this up, the value I get is in angles. Or degrees, not angles. They're all angles, but I get it in degrees, and I want it in radian. So I'm going to multiply it by degrees to radian. So this will convert the y rotation to radians. Then I'm going to calculate the camera's forward. Also, I'll just call this cam forward, or FWD, which will be a new vector 2. And to pull this off, I'm going to call mathf dot sine of our cam rotation y by our mathf dot cosine cam rotation y. What this will yield is a unit vector that points in the direction that the camera is facing. And with that, I can use that to determine where we are in space relative to the camera. So I'm going to do a couple of checks. This says if vector 2 dot distance, and I'm going to take our current patch location, and I'm going to check that against our position of the patch. So I'm going to check this patch's position against our current patch position. And vector 2, so current patch location. Oh yeah, finish the equation. So if I'm less than or equal 1 patch away, I'm going to go ahead and add that patch. So I'll go to patches dot add, and then I'm going to take our position by a new terrain patch. I'm going to have to come back here as well, but I'm going to give it a position by our priority. The priority for a position that is right underneath or right near our player is going to be a high priority patch. And then for every other patch that's there, I'm going to do another check. And I'm going to check to see if we're in the direction that the camera happens to be pointing. To do that, I'm going to use a vector 2 dot product, and I'm going to compare the camera's forward direction with the new terrain patch. Oh, hold on, jumping. Camera forward with the direction of our patch. To get the direction of our patch, I'm going to use the position minus our current patch location. I'm going to normalize that so I have a unit vector in that direction, and I'm going to compare that, and let's see, I think I need, yeah, okay, that matches up. And what I'm going to do is I'm going to check that the vector that gets returned from the dot product, or the value, sorry, not a vector, because I get a scalar, I get a float back. I'm going to check that that float is going to be greater than 0.5. So, Control Y. All right. Basically, what a dot product is going to do is it's going to return me a number between -1 and 1. If I get a value that is 1, I know that those two vectors, the camera forward and the direction of the patch from the current patch, is exactly the same, meaning they point the same direction. If those two values are at a perpendicular angle, meaning 90 degrees, I get a 0 back from this. If they're 180, if they're pointing in completely opposite directions, I get a -1 back. By checking that I am greater than 0.5, I can ensure that the patch is within a 45-degree angle of the direction our camera is pointing. So if you would imagine, let's see, nope, I don't have Photoshop open. Let me open Photoshop real quick. I'll make this a little bit easier to understand what's going on. So did I mention it would be really nice to have an SSD in this?
I don't know, a few million times.
Of course, it would also be nice to be using one of my faster machines for developing, but I'm not complaining. All right, so let's just open up a blank document. So if I were to create a vector, so let me go ahead and put an end arrow on this. All right, draw, that should be fine. All right, so let's say our camera is pointed straight up. And I can turn this off. All right, I'll also change the color. So let's say I had a vector that was pointed straight up as well. And let me Control Z, make a new layer for this one. So let's say I had another vector and it was pointed in the exact same direction as our original one. If I took these two vectors and did a dot product on them, what would be returned is the value 1. If I were to take this vector and have it at a perpendicular angle to our original vector, the dot product of these two would be 0. If they were complete opposite in direction, what I would get back would be a -1. What I'm assuming, or what I'm counting on, is the fact that if I were to draw a vector at 45 degrees, now both of these are unit vectors, meaning they're normalized and their length is 1, or magnitude is 1. If I were to look at these two vectors in either direction being 45 degrees out from our camera direction, this is going to return a value of 0.5. So as long as I do a check that says that this value is greater than 0.5, I know that our patch is somewhere in this direction. Now, our field of view of our camera does come into play with this, and I'm completely disregarding that in this aspect, because by default, the main camera is set at a field of view of 60, which means we're only checking about 30 degrees in each direction. So by checking for 0.5, I'm allowing for some overlap, so we can check patches outside of that area as well. And if you were to start messing around with the field of view of your camera and you went up to 90, you might find that some of the patches on the outside edges aren't showing up. So if you want wider depth of field of your camera, or you're finding that 0.5 isn't working for you, you can just take that number and decrease it to, say, something like 0.25, and that would give you a range somewhere out to here. And if you went with a value of 0, of course, you'd end up with a 180-degree sweep. So it's just a matter of how tight you want to make this view for loading in patches. I just happen to find that 0.5 works well for me, so that's what I went with. So, but it's completely up to you what you want to use.
Okay.
All right, now back to code. So if we are greater than 0.5 and we're not less than are or less than equal to 1, we're going to create patches again. So I'm going to add these patches. But because they're not less than or equal 1, they're not as critical to be done immediately. So I'm going to set them to a medium priority. So with that, I need to also check a couple or change a couple of things in our terrain patch, because I had mentioned that as we bring more and more things online, we'll have to revisit the terrain patch. One of the things that we have to do is create a new constructor, and we need to create a new field as well to go along with this. So what we're going to do is in our terrain patch class, we're going to make a private read-only field called TerrainManager, and we're going to call this TerrainManager. So here, and cannot, oh, it's got to be static? No. Oh, that's because it's static. Hey, I don't need that anymore. Sweet. Even better. I told you I was doing this on the fly, so all bets are off when that happens. All right. But what we do have to do, what I was going to do is because TerrainManager was initially instantiable and we had multiples, the terrain patches had to know what TerrainManager that they belong to. Now that there's only a single TerrainManager, I don't need to take that into consideration, because all patches are going to belong to the only TerrainManager in the whole project. But the reason we needed to know which one is, if you remember in Setup Mesh, one of the things that we did was reparent the mesh object, and we put a stand-in to just parent it to null. Now we're going to parent it to the TerrainManager.terrain object and its transform. So we can take everything and parent it to where it needs to be. And we're still not using the player position. And why are you upset? Oh, fine. We'll rename you to make you happy. All right, so now that's just capitalizing the tile side count and then refactoring it accordingly. And then we'll come back to player position in a little bit. So we can go ahead and do all that. And I guess we can go to the train demo, turn this off. So Control K, Control C. And TerrainManager fixed update, all that's in place. Yeah, the worst I can do is blow it up, so let's see what happens. Aha!
Well, I don't see explosions.
Yeah, I know. I was kind of shocked too. But I did mess something up.
I see that. That's awesome.
So if you ever see this, after a while you go, yeah, I put a Z and a Y instead, so I need to figure out where I did that. All right, so let's figure out what's going on. That would be over here. Ignore it for now. So inside of TerrainManager, somewhere I put something wrong, quite possibly here. So this needs to be a new vector3 position.x, comma 0, comma position.y. Take this code here and place it there. All right, let's see what happens now. That was interesting. Well, what was weird is because the camera angle looked like it was backwards, and it's gone, what did I mess up now? But as we can see, the patches that we've got are only created in the direction that we are currently facing. We're also seeing that we are a certain units away, but because we're standing on this patch, everything within a distance of 1 got created in addition to the ones in the direction that we're facing.
Right.
So if I swing around, we can see other patches get created.
Nice.
If I start running around, we'll see that eventually, hopefully, more patches get created. But they won't happen. You know why?
Well, you
Because
don't.
I'm not sending in the player's position.
Oh, I see.
Because I'm just checking current location, and current location is, or our current patch location is based off of our player position, and at no point am I adjusting the player position. So what I need to do is inside of fixed update, I'm going to need to take in the player's position. So I'll take in a vector 3, and this will be player position. Yeah, I'm trying to think. Is this lowercase? Yeah, I did do that, didn't I? All right. My player position. Refactor that. And then we'll set my player position equal to player position. So that should allow our current patch to update the way it's supposed to. Let me go ahead and duplicate this for our update. So we'll get all that. Now I need to update inside of here. And to get this, we can call tp controller.instance.transform. Yeah, dot position. This will give us a way to pull up Shannon's position. And then I can just pass these in. Switch over, run it again, see what happens. Alright, so now if I run, are we going to get some updates? Hey, look at that.
Nice.
So, and it's a much more elegant solution than what we had before with the really nasty list and the 4 different methods to calculate when we needed a new row.
Mm-hmm.
So much more efficient, almost magical, if you would.
Almost.
So, but and we're still running at a nice 600, 650, 592. So we're getting some nice, decent frame rates out of it.
Very cool. So where does that put us with TerrainManager now?
I think 2 videos in, 3 videos in.
Yeah, 3 in.
3 in. So we've still got our update that we have to go and implement because all we're doing is creating new patches. We still haven't dealt with when to hide patches because right now we see everything that gets created.
Right.
We're creating them much more efficiently, but we're not hiding anything. We're also not removing any of the patches. So we've got to implement all of that stuff, which we'll do in the next video, or a good part of it. I think we'll implement all the helper methods in the next video. And then the video after that, we'll come back and we'll get those helper methods in place inside of the update method. And then we're going to have to revisit our patch builder because our patch builder is not calling the list yet.
Okay.
So we'll have to deal with that as well.
All right. Awesome. Well, with that, that is going to conclude this video, and we'll see you guys in the next.